All the way from Pittsburgh, our industry spokesperson, Mr. Ken Komoroski, and he works for Cabot. And if I could, he has represented Cabot Oil for more than 20 years. He is a partner with a law firm in Pittsburgh, K&L Gates. He has active practices in field of oil and gas law and environmental law. In addition to representing Cabot, Mr. Komoroski represents several independent producers of natural gas and oil. Prior to beginning his law practice, Ken was an environmental engineer and supervisor for a chemical manufacturing company. He received his BS in environmental engineering from Penn State, waste, water, and water treatment specialization. Please welcome Mr. Komoroski.
Thank you very much. Thank you for all attending tonight, and thank you especially to the League of Women Voters for hosting this event. I've got about 15 minutes is what they give me to speak, and there will be question and answers later, so I'll move through relatively quickly, of course. And I'm going to talk generally about the water quality protection measures in the industry, and I'll also spend a few minutes at the end just giving you a very brief update on the situation endemic as we see it. And what I'd ask you, I think the most important thing is that everyone forms their opinions based on the information they have available to them. And so the more information you have, the better able everyone is to make reach their own opinions and conclusions. And we think the League of Women Voters does a great job putting forums like this together to help present a balanced piece. So with that, I'll say too, and maybe this would be a question I get in any event, but I'll answer it just on the possibility that I will. Cabot's position is that we are in favor of public disclosure of additives to frac fluids. We think that's a good idea. And we're also in favor of EPA study of hydraulic fracking, hydraulic fracturing, and any potential impacts on water supplies. We think those are both good ideas. Okay, so this is the overview of my presentation for this evening. We're here to talk about our water resources, and this is a state that's blessed with abundant water resources, great water resources, important for drinking and many other purposes. So, and obviously that includes not just surface water, rivers and streams, but groundwater as well. So the water uses for the Marcellus Shale development are drilling and hydraulic fracturing. Yes, some water is used to create, and the mud that's used to drill the well. That's a relatively small amount, and a relatively larger amount is used for hydraulic fracturing. And I'll get into that in a little more detail in a moment. And an important topic here, of course, is the flowback water. After you fracture the well, then after you fracture the formation, some amount of water flows back, and that the basic options for that are to reuse it or to treat it and dispose of it. Okay, now you've probably seen slides like this a lot of times, and we're focusing more on the water quality aspect of it, but just to show the geographic reach of the Marcellus Shale and how many counties and how many people are involved in it, are affected and will be affected by this development as it goes forward. So it's very extensive, very large. It's the largest shale play in the country area-wise. And just a few days ago, I was approached because the oil minister from Qatar, Qatar has the largest natural gas field in the world, wants to come to Pennsylvania and meet to discuss the Marcellus Shale because this is the second largest natural gas field in the world. All right, one thing, again, I talked to a lot of people. I've spoken with a lot of folks who live here in Dimock, and I've spoken to a lot of media representatives. And one of the things that I think is not well understood, and if you got it down, great, and I'll bore you with the next part, but if not, there are 4 phases of development when you're going to produce gas. The first is site construction, and that is construction. I mean, it's bulldozers and backhoes and leveling out an area, 5, 6, 7 acre pad, putting rock on it. There's nothing that's specific to oil and gas activity at that point. So that first phase is site construction. And each of these phases, it's important because in respect of what controls need to be in place in order to protect the water. Second is the drilling of the well, and that after some period of time, it could be the next day, it could be a month later, it could be 2 years later, you bring the drilling rig in to drill the well. And that's the part where you use maybe thousands of gallons of water if you're drilling with mud. You can drill on air to drill the well. That mud then ends up in a pit and is either remains on site or is hauled off site. The third phase is well completion. Now that's the term the industry uses, but that's the part where hydraulic fracturing occurs. And that's where, and I'll talk about this more again specifically, greater volumes of water are used. And the fourth is the production phase. And that's, the site construction takes a week or two. Drilling takes 30 days, 30 to 40 days. Well completion, actually, depending on how many stages, that could be done in 48 hours, 72 hours per well. And then production is what occurs for decades. And so after all the initial activity, what you'll see for 40, 50, 60, 70 years is the wellhead, a few tanks, and some metering equipment on the location. And that has a much, much smaller footprint. So the measures that are in place to take care of the water quality, to protect the water quality, are erosion and sedimentation control. And that, in the construction phase, that's just critical. That's when you're turning dirt, you've got to make sure the measures are in place. Stormwater management, that's really the same issue for us. Although we have to make sure too that there isn't an increased flow that comes from our locations that causes problems for the folks downhill. Preparedness, prevention, and contingency plans. Now that's a program that's been in place for a long time, administered by the DEP. But that is what is used to make sure that we look at what materials we use on location for construction, drilling, fracturing, and make sure that we have measures in place to prevent those from entering the environment. And finally is site restoration. And that's a very important one, because once we go to the production phase, then, and we're required by law to recover the site, to reclaim it, seed it, mulch and seed it, grow grass, restore vegetation, and all of that is works effectively then, so that there really is, at that point, once the site is properly reclaimed, no opportunity for pollution, any water contamination from a well. Okay, now, these aren't the best pictures, but they are pictures, and they're not to say that that's the same location, but just fundamentally, the active drilling is a drill rig, and they come in different sizes. The pads can be much, much larger than that. That, I don't know how large that one is, but one of the things that the industry is trying to do, and Cabot is trying to do, is to drill as many wells from a single pad, use horizontal drilling, and so you use a larger pad for that. Now, the bad news is you'll use a larger pad for that. The good news is that a single pad can eliminate the need for 45 different surface locations. So we think that's a good thing. Following restoration, and look, it's got the pretty lavender flowers in the front, but that's not the point. The point is that the ultimate footprint, what you will see, what you will live with as residents in this area, is going to look like that. Now, if it's a pad that has multiple wells, it's going to have more than that. That in the foreground of the pad itself, there would be more than that, and the pad area could be larger. So I'm not saying that's as small as they typically are. That's just the picture I had available. But the point is, again, that most of the disruption and what happens to the roads, especially this time of year, I mean, it's a disruptive practice. It is. But at the end of it, this is what we live with for a much longer period of time. Okay, water use. Pulling the water out of the streams and using it for hydraulic fracturing. That's administered by the Pennsylvania DEP. You have to submit a water management plan to the DEP and have that approved. And all drilling has to be done in accordance with an approved water management plan. And the application form is 4 or 5 pages, quite a bit of information. It's all designed to make sure that the withdrawal of water does not have an adverse effect on the stream from which it's withdrawn. Also, depending on where you're located, and of course in this area, the Susquehanna River Basin, is the Susquehanna River Basin Commission has a very extensive approval process, and if you're east of here, Delaware River Basin Commission has the approval process. Okay, so, and this is the activity that I want to talk the most about, and the last bullet item, probably evokes some response, but that's scientifically correct. And that's not a surprise. That's not an accident that there haven't been documented cases. What we focus on is the surface spills, the surface issues. That's where we have the potential to adversely affect water supplies. That's where we have to be the most careful. The hydraulic fracturing, again, we're in support of the disclosure of what the additives are, but they don't get into the water because there's really, scientifically, it's somewhere between awfully darn hard to impossible for that to occur. But there is the potential during drilling, during site construction, during trucks moving in and out. I mean, there have been diesel spills, and there have recently been diesel spills, and that's from the equipment itself. The activities on the surface are where we focus our energies, where we're not perfect, where we work hard, but that is where we have the potential to affect water supplies. Hydraulic fracturing simply does not have that potential. So and that's because of the design of the system and the fact that well, look, I mean, whether you call them additives or chemicals, they're the least important part of the process to us. The volume of water and using 10,000 pounds of pressure to crack open that rock 6,000 or 7,000 or 8,000 feet deep, that's what we need. And then we need the sand to hold open the cracks. And these other elements of it help to keep the sand suspended, help to reduce friction, help to avoid bacterial growth in the well, things that can adversely affect performance. But that's just not the big part of it. So in the industry, I mean, we simply can move more and more in a green direction. We don't have to use things like petroleum distillates. We don't have to use things like that. So we can continue to move in that direction. Cabot is moving in that direction. And I'll come back to this later if I have time, but the other thing is that at present, Cabot is reusing 100% of the water that flows back from the wells. That has not been the case initially. That is the case now. Okay, now this isn't to scale, and I still haven't found one that is to scale. Maybe it's because there isn't one that fits on a screen or you can't see anything, but the important point here is that the thicker blue line, at the top, well, the freshwater supplies are maybe at most 500 or 600 or 700 feet deep. Where we're fracturing the Marcellus is 7,000 feet deep. So the injection of those additives in that water and that sand is so far below freshwater supplies, it is impossible for that to affect water supplies. Now, again, if you spill it on the surface, yes, it can. If there was a problem with the several series of casings and steel casings and cementing at the surface, yes, it can. But it hasn't in tens of thousands of opportunities to do so. And as at least a former engineer, that tells me a great deal. So again, disclosure of that and study of that is only going to help reinforce that that's not where the issue is. The issue we have to focus is on surface activities. Right, and this is a bit more about the protection of water supplies. Now this goes more towards the drilling and the casing and cementing standards, and these are DEP standards. These are requirements for anyone who drills wells. And again, if we had more time, we could go through them. I've seen some great, where you actually have the pieces of casing and cement to show the levels of protection that exist in the well. It's absolutely in your interest for us to protect water supplies. It's in our interest to protect water supplies too. It's not a good thing when water supplies are adversely affected. All right, flowback water. Let's talk about the volumes. And again, you form impressions based on the amount of water. Given the number of stages in a horizontal well, and one of the things from that earlier picture, this is what would be called a 6-stage well, because there's 6 points along that horizontal lateral where you're going to do fracking, and you do each one in succession. 1 stop, 2 stop, 3 stop. So, but if you're going to do a 6-stage well, you're going to use 3 to 4 million gallons total for hydraulic fracturing, about 600,000 gallons per stage. And actually less water is flowing back from the Marcellus than has been flowing back from conventional well drilling in Pennsylvania, considerably less. So that's less water to have to deal with, and that's actually made total reuse an opportunity in many, many parts of the state. Most importantly, no, not most importantly, but another important element is the contents of flowback. It's heavily, heavily salt laden. Geologically, this gas comes from receding oceans. So these were formerly oceans, and that Marcellus shale is decayed biota from an ocean that existed here, I don't know how long ago, but the salt and the minerals and the gas, which is the decomposed organic matter, is what the Marcellus shale is. Now, there is, in addition, whatever additives that we put in, but at that point, now it's diluted even further, but that comes back up the pipe. That never enters the water supply unless we spill it on the surface. If we're putting it into a truck to haul it to the next location, we're in a pipe pumping it to the next location to frack the next well, and we spill it, that can affect water supplies. That's what we have to avoid. That's what we have to concentrate our efforts on. Okay, as I said, options for hydraulic fracturing water is we can blend it with fresh water. We can take that flowback water because the volumes are small enough and we have enough new activity going on that we can blend it up and continue to use it for hydraulic fracturing. You can treat it, and in theory you can dispose of it by underground injection. There isn't a great deal of capacity in Pennsylvania, geologically speaking, for that last option, so it isn't used to a great extent. Okay, so in summary, protection of water resources, surface and groundwater. First of all, prudent use of water supplies. We have to make sure we're pulling from a stream that can handle. The Susquehanna River itself, we talked about using 3 or 4 gallons. The Susquehanna River flows south of here, down in the Harrisburg area, 19 million gallons per minute. So, and this time of year, and with what you can see in the streams around here from the snow melt, pulling water out of a stream would actually be a good thing. In the summertime, we have to be much more careful and actually have to avoid, where we can, pulling from small streams. Next, prevention of surface spills. That again, I said it probably 4 times already, I'll say it a 5th time. That's where if we don't do things well or prudently, that's where we have the potential to contaminate water supplies, to contaminate the soil. And it has happened. We've had diesel spills, we've had spills of hydraulic fracturing fluid, and we have to avoid those when possible. The reality is it's going to happen. It's never, ever acceptable. There isn't a certain number of them that we tolerate. Our goal is 0, but they do happen, and we have to avoid them. And when they do occur, we have to clean them up and meet full DEP cleanup standards. And the DEP has an excellent program that makes sure that the environment is protected when it occurs, and that's the process. Proper drilling practices, and I'll come back to this in a minute when I talk about Dimick specifically. And if proper practices are used in drilling the well, it's a very, very, very rare occasion that anyone's water supply is affected, and in most of those situations, the vast majority of those situations, it's temporary. There are those rare few where it's longer term and more serious, but that's few and far between. But drilling the well using proper techniques, circulating the mud back to surface, proper casing and cementing, implementation of that all does protect water supplies. Management of flow back and produced water. Proper management, like I said, we've got to make sure that if we're going to reuse it, that we keep that in line impoundments and in pipelines that don't leak or spill. And when we have to treat it or dispose of it, we have to make sure it goes to proper facilities for that treatment or disposal. Finally, reuse of water, and that's a wonderful thing. That not only does that eliminate the introduction of those materials into the environment, but it also reduces the amount of water that's needed to be pulled from streams. So I got the 2-minute warning. So what I'll do is shift then to the current situation in Dimick, and we have been continuing to evaluate the presence of methane in the water supply have not reached final conclusions. There is the possibility that, well, first of all, it's clear to us and clear to the DEP that Marcellus gas did not have any effect on the water supply. The methane that's in the water supply endemic is not Marcellus gas. It came from a much, much shallower formation. That we know. We don't know for sure how it got there. It is possible that the methane in the water supply came from one well where there was a problem, where a well was being drilled and the soil and rock collapsed around the equipment while it was being drilled. We were unable to recover that equipment immediately. It is at least a theoretical possibility that that allowed migration of gas from 2,000 feet to 500 feet and allowed it a pathway to get to water supply. There are measures in place to ensure that cannot ever happen again. Whether or not that was the cause, it's possible that wasn't the cause, but if it was caused by Cabot, that's our most likely culprit. So we're continuing to focus our efforts there, continuing to work with the department, and making sure as best we can to do the right thing. Thank you.
Thank you, Ken. Our next guest is with DEP out of Harrisburg, Mr. Scott Perry, who is the director. And this evening he is going to talk to us about the proposed total dissolved solids standards. Mr. Perry?
Well, thank you very much, and I really appreciate the number of folks that are out here tonight that are concerned about water resources here in Dimick, because I share your concern. It's the reason why I'm working with the department. I'm very passionate about protecting Pennsylvania's environment, and in particular water resources. I think there's one area where Ken and I can really agree, and that is groundwater contamination from oil and gas well drilling is not acceptable. When it does occur, it needs to be remedied in an expeditious basis. And what I want to do today, actually, is spend a little more time talking about the potential impacts of well drilling generally on water resources. But I wanted to address some of the comments made by Senator Casey's staff person today. If anyone is interested in what chemicals are being used in the fracking process, my office has the material safety data sheets from every company fracking in Pennsylvania. We have the list of every single chemical that's being used in the fracking process, and it's public information. We're going to make that list available. If you want copies of the material safety data sheets, we can make that available as well. So we have that information, it's publicly available. The other thing I just wanted to touch on quickly was a question in the audience questioning whether the FRAC Act was going to fix a Clean Water Act exemption for fracking. There is no Clean Water Act exemption for fracking. It's solely under the Safe Drinking Water Act. The Safe Drinking Water Act has a program that regulates injection wells to prevent contamination of underground sources of fresh drinking water. So that's why it's if you want to regulate fracking under the Safe Drinking Water Act, that's where to do it, not the Clean Water Act. Obviously, you folks are a pretty well-educated crowd. You know that Pennsylvania is the birthplace of the oil and gas industry in North America. And Pennsylvania was really the focal point of that development. We estimate that almost 315,000 wells have been drilled in Pennsylvania since 1859 when Edwin Drake drilled the Titusville well. We have information on about 215,000 of those wells. We have about 120,000 active wells in Pennsylvania. So there's been a lot of activity, but needless to say, it hasn't looked like this. This is a much more sophisticated play, and the equipment and processes that are being brought to bear are in fact a little different than what we've seen, but we've been able to adapt the regulatory programs to meet those challenges, and I want to talk a little bit about that. So here's the topics I want to go through. I want to talk about from the start to finish with well siting and completion, and how those activities have the potential to impact fresh water, water resources, and what we're doing to make sure that that doesn't happen. Before I get into it, I want to get into some statistics on well drilling activity in Pennsylvania. When I started with the department in 2000, I came there as the attorney. I was the lawyer for the oil and gas program. And the director then told me that he thought his job was to put the oil and gas industry to bed. It was a dying industry that was on its last legs. But needless to say, the demise of the oil and gas industry has been greatly overstated. We had seen record years of well permitting up until basically this past year, where we went from about 8,000 wells to about 6,240 wells permitted. Surprisingly, the bulk of that permitting activity is not Marcellus shale. It still remains the minority of well permits that are issued in Pennsylvania. However, last year was a very significant year. We were expected to receive even more permits this year. We had received industry quotes in the neighborhood of 5,200 Marcellus well permit applications, but so far that just hasn't been the case. In fact, in the first quarter of this year, we've received less than 600. So we're basically on pace to meet that same number, and it looks like we're going to have about the same number of traditional wells permitted in Pennsylvania. So here's where all the activity is taking place. The red numbers are the total wells, and the blue, red are permits issued and wells drilled. Oops. Usually what we see is about a 3-to-1 ratio. For every 3 permits, the 1 well is drilled. And you can see where all the activity is. Obviously, Susquehanna, Bradford, Tioga, very much the center of activity for Marcellus. Obviously, there's a number of well permits being issued in our Allegheny National Forest for shallow oil drilling. Down in Washington County is another hot spot for Marcellus well drilling. Areas like Armstrong and Indiana remain largely for our shallow gas industry. Oops. This is where our Marcellus wells are being permitted and drilled. Obviously, only 768 wells drilled last year. We have about 1,090 Marcellus wells in the Commonwealth. Actually, we've also got about 11,000 permitted wells that are deeper than the Marcellus. That would be like the Robeson well that I'm sure many of you have read about, penetrating the Oriskany Formation. But here's where all that activity permitting activity is taking place. And if a little bit of an easier viewpoint, the blue is our traditional wells, and the red is Marcellus. Obviously, lots of activity in Indiana and Armstrong County. It's been going on that way for quite some time. The laws that we administer at DEP, and that's my job. My job is to administer the laws that have been developed by the legislature. The Oil and Gas Act is a primary vehicle by which we do that. We have 2 other statutes. The Coal and Gas Resource Coordination Act does just that. It coordinates the development of those 2 mineral resources through some spacing. I wanted to take a mention of the Oil and Gas Conservation Law because there has been some interest in pulling the mark. This is for our deeper wells. It's a correlative rights statute to protect homeowners. If you drill a well, if your neighbor drills a well on their property, traditionally in a sandstone formation, you might say he's stealing your gas. And this is a statute that has an ability to unitize those interests so that you apportion the royalty. It also has the ability to forcibly integrate interests so that whether you want to lease your land or not, you could be considered a non-consenting owner, and your property would be integrated into the unit. There's been some interest in seeing the Marcellus shale be pulled into that for a number of reasons, of course protecting correlative rights being one of the primary purposes, but I just want to make a mention of that statute. The permitting process, you saw we issued 8,000 permits basically in 1 year, so it's not a particularly onerous permitting process. It's focused primarily on well site location, and one of the big issues that's been to the forefront is well drilling in floodplains. And I just want to take a second to address that. As I said, it's my job to uphold the statutes that we have in place, and right now, well drilling in floodplains is permitted. There are a couple ways that we do regulate it. For example, well sites have to be 100 feet from streams located on a topo map. If you're within the FEMA floodway or 50 feet from a stream where it doesn't have a FEMA floodway, you need to get a dam safety encroachments permit. But then there's also the opportunity for municipalities to regulate through their zoning ordinances under the Floodplain Management Act these activities. So there is the opportunity for regulation of the well locations relative to streams. One of the other, I think, important environmental protection features here is pursuant to our regulations, you can't use a pit to contain your residual wastes if the bottom of the pit's going to be within 20 inches of the seasonal high groundwater table. So what that means, if you're close to a stream, there's a distinct possibility that you're going to have a shallow groundwater table. You're not going to be able to use pits to store your residual waste. You're going to need to use tanks. And that's from my perspective, that's a significant environmental protection measure where you don't have flowback stored on site in a pit near a stream where flooding can occur. So those are some of the measures we've taken to make sure that the environment's protected when we're drilling in floodplains. Erosion and sediment control has been one of the most, I guess, controversial issues for the oil and gas industry since I've been here. Drilling wells can be muddy practice, but in Pennsylvania, unlike many other states, if you're going to disturb more than 5 acres, you're going to need a permit from us to do it. We want to see best management practices to control erosion and sediment at the well site. You're going to have an erosion and sediment control plan. If you want to take advantage of our expedited review process, that plan is going to have to be developed by a licensed professional who's attended DEP training. We're very serious about having quality plans on site so that the contractors can construct these well sites and access roads in a manner that doesn't cause a lot of sediment into our streams. Sediment loading is, I think, the #1 cause of degradation to Pennsylvania streams, and these are the kind of practices that are basic. They're must-haves, and we have been seeing a pretty good. Operators have been doing a pretty good job here, but we always need to see. There's always room for continuous improvement, and this is one of the areas that we really focus on when we're inspecting sites. The department is, once you've developed your site, you're going to have to drill your well, and right now we've got a regulatory process to improve our casing and cementing standards. We want to see casing that's attached to blowout preventers that's pressure tested to make sure there's no leaking. We're having new cementing practices implemented so that we can avoid groundwater contamination, particularly from gas migration. Protecting public safety from gas migration is definitely a top priority for the department and my top priority as the director for the oil and gas program. These new regulations are going to assist us in ensuring we don't have gas migration occurring. And part of that, if there is a gas migration event, for the first time the burden is going to be put on the operator to go out and investigate that complaint promptly, report it immediately to the department rather than waiting, I guess, for a homeowner perhaps to call. So we've got more standards for that. We've also are developing standards for our existing wells, because frankly, some of these we've got wells in Pennsylvania that are producing that were drilled in 1900, and we need to have routine inspections downhole of the casing of those wells, make sure that they're structurally sound, make sure that the well pressures are low so that there's no possibility of gas or oil escaping from the wellbore into the freshwater zones. The comment period on the advance notice closed on March 2nd. We're going to have a new draft available for our technical advisory board on March 25th. Then we're going to have a second round of public comment where it's going through the proposed rulemaking process. I hope that's going to start in May. So if you didn't comment this time, you have another opportunity. Keep your eyes on our website for the second round of these regulations. And if you have concerns, please provide comments to us. I mentioned, I keep talking about water supply protection, and this is really one of the areas where the Oil and Gas Act has the sharpest teeth. If groundwater, drinking water supplies are polluted or diminished in any way, the operator has to restore or replace the supply, period. If the contamination occurs within 1,000 feet in 6 months of well drilling, they're presumed to have caused that contamination unless they've taken a pre-drilling water supply sample. One of the other ways that they can rebut this presumption is if the homeowner refuses to allow them access to the property to take a sample. So if an oil and gas well operator comes to you and wants to sample your water supply in advance of drilling, let them do it. If you don't, and there's a contamination of your water supply, and it's one of these close calls, we don't have the presumption to rely on. So we want your cooperation with that. You would only be hurting yourself if you refuse to grant the operator access to take a sample. After you've drilled the well, now you've got to complete it. Where are you going to get your water? We work cooperatively with the Susquehanna River Basin Commission to evaluate water withdrawals to protect water quality. There's a direct connection between water quantity and quality. And we've based our evaluation on low flow conditions. In fact, it's based on the 7 lowest flow days in a 10-year period. So extreme drought conditions, evaluating extreme conditions under those hypothetical circumstances, and then limiting the amount of water an operator can take if, say, they're taking more than 10% of that number. So we're very protective of, especially our headwater streams where a lot of this activity is taking place. And outside of the Susquehanna River Basin, it's just the department. So we're implementing a new program across the Commonwealth that's never been done before, and I think it's been successful. We've been protecting our streams from over withdrawals. Once you've gotten your water, you need a place to put it. And one of the advents for Marcellus has been the use of these centralized impoundments. I call them centralized impoundments. It's basically just a large impoundment that's going to service multiple wells, multiple well locations. They can be there for many years. If they're storing fresh water, they are basically treated like a farmer's pond. The farmer can go out and build a pond for his cows, and they don't need a permit from the department to do it unless they disturb too much earth doing so. But once they start storing wastewater, I don't care how big it is, they're going to need a permit from us to store the water there. We're going to make sure that the site is structurally sound, and we're going to make sure that it's got an appropriately lined liner in it. They're going to need to have either an underdrain system in it or groundwater monitoring so that we know that the groundwater is being protected. And I'll tell you that this is an area of one of my greatest concerns, because you're talking about a lined impoundment that has the potential to leak that's storing wastewater in it. This is a source of regulation I think we're going to need to be evaluating continuously. We need to be inspecting these sites continuously to make sure that there isn't any potential for contamination occurring there. Wastewater management has been a particularly, I guess, troublesome area because the TDS levels in the frac flowback are high, and the initial flowback period, the TDS levels approaches that of the ocean, 35,000 milligrams per liter. We've seen TDS levels approaching several 100,000 milligrams per liter. And where you take that needs to be reviewed by the department. Only facilities that have our approval can accept this wastewater for treatment and disposal. We also manage the entire process under residual waste regulations. We require a complete chemical characterization of that wastewater. We're getting all of the data in now, so we know exactly what's in it. They're going to analyze for the heavy metals. They're going to analyze for naturally occurring radioactive materials, radium 226 and 228. We're going to know what's exactly in that flowback and make sure that our streams are protected. Part of that protection is the new TDS strategy that the department's embarked on. We had proposed regulations offered for public comment, and that comment period's closed. We're evaluating the 4,000 plus comments we received on it, and we'll be moving forward through this process with our stakeholders. But just briefly, if you are proposing a new or increased discharge of a high TDS content, TDS being total dissolved solids, includes sulfates from our coal mines and chlorides of particular concern with oil and gas well drilling. If you're going to have a high TDS discharge, the plan right now calls for a limit on that to 500 milligrams per liter. That's actually the drinking water standard. So the discharge will be, and a TDS level will be as clean as the drinking water standard is for underground injection control, but nothing so far. The commercial wells, I think there's only one commercial well in Pennsylvania for brine disposal, and its capacity is something like 800,000 gallons a month. So if you've got a well that's flowing back 1 million gallon in 30 days, it's just not going to be possible to handle that much wastewater. We're hopeful that new treatment technologies will emerge. It's been really great to see the amount of recycling that's going on. In the Susquehanna River Basin, out of all the water that's withdrawn, only 4% is actually being disposed of right now. You have the reduced flowback, and then the increased amount of recycling has limited that amount that needs to be disposed of. So I think it's a problem that we're going to be able to effectively manage, especially as we're seeing new technologies come online. There are a lot of ongoing issues that we're dealing with. obviously need to see more treatment technologies for dealing with this wastewater. Continuing to evaluate naturally occurring radioactive materials that are present in the wastewater. We're very concerned about the potential buildup in the sludges at the treatment plants. So we're evaluating and studying that situation now. The data I've seen has been very encouraging with regard to the discharges from the treatment plants that are taking this wastewater. There was a number of newspaper articles mentioning how high the radium-226 and 228 gross alpha and gross beta is in the Marcellus shale flowback cited up in the New York State study. But the discharge levels we're seeing is actually around 1 picocurie per liter, which is less than the 5 picocurie per liter drinking water standard. So the discharges from our treatment plants are less than the drinking water standard. So that was, I'm pretty encouraged to see that data, and I think it means that our environment's protected, it means our drinking water supplies are protected. Air quality, I know you talked about that last week. It's a topic that the department is definitely not ignoring. We're going to be going and evaluating the air quality impacts at Marcellus shale sites, everything from the compressor stations to the drilling process. So it's an issue that we're very much aware of, and we're evaluating it and really looking to address it. That's me. If you have any questions, please contact my office. I'm out of time, but I really appreciate your attention. Thank you very much for having me.
Thank you, Ms. Mary. I think one of the questions we might want to attend to when the time comes is the cases that Jim just brought forward. While we're on the subject, those last 2 slides, could you explain how that happened?
Oh yeah, absolutely. Can we bring this back up?
Yep.
I think one more. Go back one more. Right here, it's basically looking at, this first case study was looking at a gas well, okay, that was installed in rock. And the point here is that you've got a lot of overburden. So this would be in your valley, typical case in your valley, where you've got a lot of sediments and whatnot. And so basically,
I don't think they can hear you. Can you please use the microphone?
Yeah.
So basically what happened is that it basically came through the fractures and then entered this, what they call unconsolidated zone. So this is just one typical scenario that they had in this study. The second is actually a surface study. If you notice right here, you've got this pit, and basically things migrated from the pit through the water table and whatnot, and it eventually got to the well. See, as this water is flowing, remember when I had the sponge and I tipped it, okay? Water is flowing from a higher elevation to a lower elevation, and then when it gets through the well, close to the well, it's not only migrating horizontally, but it's also vertically if you have, especially if you have a well, because these fractures, these joints and fractures basically connect this open well, open hole to contaminants in the unconsolidated zone. This shows an aerial view of the pit, and then basically this would be called the contaminant plume. The last one is much deeper. Basically you have your gas well, here's your bearing zone, and then what they're trying to show here is that there are natural fractures in the rock, and basically it can provide a conduit for gases to migrate upwards and get into these water-bearing zones, which, here's your potable wells here, and here's your sandstone, and basically it's migrating in that direction, and then can potentially impact your well. This one happens to be more of a surface spill. It's what they're talking about here is that I guess they were using brine to keep the dust down, and there were some problems along this road, and they have these lines of topography here showing that this is a lower elevation. So basically this stuff was rolling off the road, and they were using it, applying it, so over-applying it is what they were doing. Eventually it basically impacted the well. All right, and what they're showing here is that if you're in low permeability soils, it's not going to migrate vertically. But if you're in higher permeability soils, you might have a problem. Okay. You're welcome.
Can I ask Jim a couple questions while
Sure.
he's up there and we have the slides? Can we back up to the first one? The the first one you talked about. Yeah, that, no,
Sorry.
that one.
Shoot.
In this instance, again, it was in northwest Pennsylvania. How deep? They only cased the well to 270 feet.
You can use that microphone, ma'am.
My question is, that well was only cased to, I think, 270 feet or so, and because of the sloping rock, there was, in fact, a pathway for uncased material coming up through the uncased area and out into the water-bearing zone.
Mm-hmm.
And then maybe Ken can answer this. When they're casing wells in the Marcellus shale drilling, they are, in fact, casing off the entire water-bearing zone. Is that correct?
Yeah, that's right. 600 or 700 feet down.
So this circumstance theoretically would not arise. Is that correct?
Right.
Theoretically. And would you go forward to? 2 slides, please. And on this one, I believe a problem arose because of pressure building up in the well, in the casing.
That's right. That's
And-
right, we did.
Okay, and again, Ken, under what circumstances would pressure build up in the casing after fracturing is complete? Do you know? Okay. I think what happened here is this wellhead was cased off and the pressure was allowed to build up.
That's right, and it built up inside the well and then basically forced its way into the neighboring aquifers.
Okay, and
Right.
under normal operating circumstances, would that happen?
No, it would take the preferential pathway up to the surface, or I'd be pulled off.
Like,
But could it? Yeah, could it leak out a little bit? Yeah, but
okay,
less likely.
okay, thank you.
Okay, but the fact that this was capped, yes, exacerbated the problem. Thank you.
Thank you.
Okay, are we ready to begin with the questions? Yes. Okay. This can go to DEP and to Cabot. Why are most pads permitted at 4.99 acres? Does this have anything to do with the 5-acre rule? And how does this affect oversight?
Is this okay? One of the best management practices for controlling erosion sediment is to limit the size of the earth disturbance. The 5-acre threshold for the permit is there because that was the original standard set by the NPDES program. The oversight that the department has for these well sites doesn't change based on the number of acres that's disturbed. We're going to inspect the well multiple times and inspect the construction of the site to ensure that erosion sediment control measures are in place. When you disturb more than 5,000 square feet, you're supposed to have a written erosion sediment control plan that's available on site. That plan has to be implemented in the field as it's written up. Those best management practices have to be there. So regardless of whether you have a permit or not, you're going to have a written plan and it's going to have to be implemented properly. We're going to inspect that plan when we're on site, and it's got to accurately represent field conditions. The plan's got to have the best management practices in it that's going to actually control erosion and sediment at that site. If it doesn't, it's a violation of our regulations. If the best management practices aren't being implemented according to the plan, that's a violation. If the best management practices aren't containing sediment, that's a violation. We're not going to turn a blind eye to a site simply because it's smaller than another one.
I agree with all that. I'll also say that to the extent that anyone limits their pad size to below 5 acres, it oftentimes is to avoid the permitting for that location. That's direct answer. Second point is, as Scott said, it's exactly the same set of requirements for control for erosion and sedimentation, whether it's 4.5 or 5.5 acres. So we're subject to exactly the same type of control measures and requirements, regardless of the size of the pad.
Thank you. Mr. Komoroski, does your company disclose the true nature of your drilling operations and plans, etc., to a community before you commence drilling? Do you keep the resident informed and updated?
Short answer is no. We have not done as good a job of that as we can and intend to going forward. We've done what we've needed to inform the DEP and to comply with regulatory requirements. We have not done as good a job as we would like and as we intend to do going forward, and we'll work towards to provide more information prior to drilling activities in an area.
Can I just add something onto that? We have an e-notice program. You can sign up and actually get emails. When we get a permit for a well, you'll get an email to your home that lets you know where this well is going to be located. If you're interested in finding out what kind of drilling activities is going to be occurring as we know it, sign up for the e-notice program. Just go into the DEP website and look that up and sign up for it. The same thing for the erosion and sediment control permits. If that's an issue you're interested in as well, you can get e-notification when we get those permit applications.
That was my question. That's not what the question was about. The question was about, does the gas company tell people before they come into their area how invasive it's going to be, how many wells they're going to do, how they're going to change their lives? Do they sit and tell you that, or do they say, there might be a well out here?
But doing their job. Their job is not to fully explain the entirety of the drilling process. It wasn't intended to mislead anyone, but we can tell from what's happened here in Dimmick and in Susquehanna County that that there was not as much information shared as we could have and as we should have. So we just have to do a better job going forward.
Thank you. If gas companies are taking water out of local streams, what will the kayaking season be like this year, but especially in years ahead? Anyone?
Tomorrow it's going to be excellent. This weekend.
We heard that the average horizontal well requires about a 5 million gallon with water withdrawal to frack. That's the one-time use for that well. I know that a scrubber on a coal-fired power plant uses 5 million gallons a day. I know that consumptive use on a nuclear power plant is 40 million gallons a day. The amount of water being used to frack Marcellus wells is less than used by golf courses and ski slopes. The water we are evaluating, this is the only industry, in fact, that DEP is evaluating the water withdrawal impacts for. We base that evaluation on extremely low flow conditions. We assume that the stream is at an extremely stressed state when we evaluate the amount of water that can be used. If you're withdrawing about 10% of the water volume in that stream at its extremely stressed state or less, you're generally going to be approved without a pass-by. Because of the amount of activity that's being conducted, more and more pass-bys are put on. So that means you can only withdraw water when you've got a lot of water in the stream. So in these low flow months, where people are most concerned about for recreation and for habitat, which I'm a bass fisherman, I'm a trout fisherman, and I'm a canoer, and I'm concerned about those kinds of impacts myself. So when you have low flow conditions, you're just not going to be able to withdraw water.
Why did the DEP pad site take the pad site permitting away from local contact, for instance, with county conservation districts?
Counties looking at things. People are going to have different interpretations of the rules. So it was a measure to improve consistency across the state. I realize very much that the conservation districts have provided a very important role to their communities, and they continue to do so. They continue to regulate the development of the pipelines associated with oil and gas wells, the transmission lines, but the well sites themselves are going to be, the permitting is going to be done by DEP. You have to understand also that the conservation districts never enforced the erosion and sediment control program at oil and gas well sites. They never did. It was always the department. So the only thing that was removed was the paperwork review. That paperwork review was removed from the CCDs and assumed by the department. Enforcement has always been with the department, which is, I think, is the most important component of our erosion and sediment control program. Being on site, making sure those sites are stable, making sure sediment is not leaving the site.
To our water panel, what about the artesian wells and natural gas springs? And pardon me, let's rephrase that. What about our artesian wells and natural springs that are closer to the surface? Any disruption near that could likely affect our drinking water?
Yes.
The springs are particularly prone to impact from surface spills and from seismic activity, and even from truck traffic and road building. Because they are so close to the surface, they are prone to, I think Jim referred to slugs and material being disrupted, and it could even be sealed off.
That depends on your definition of artesian wells. To a geologist, an artesian well is a well where the water comes into the well and rises up to a level higher than where it came into the well. That's an artesian well. So you may have a lot of artesian wells and not really know it. To most people, an artesian well is a free-flowing well, and the free-flowing well is where the water comes up and flows out of the top of the casing. Are they subject to damage by the gas well drilling? Definitely. You're drilling for the gas wells, you're drilling down 8,000 feet, so they're going through the aquifer. And that was something that was mentioned earlier. Putting in 600 or 700 feet of casing and getting below the aquifer. Now, I don't know how they can do that, because I have seen water wells go down 1,000 feet. So 600 or 700 feet of casing is not enough.
Okay. This is to Mr. Komoroski. Does all the water, when it's placed down the wellhead, does it come back out during the process, or is there a certain percentage that stays in there? And what happens to that water?
If we're talking about hydraulic fracturing, no. As one of my slides indicated, somewhere in the neighborhood of 15 to 30% of the water that's introduced into the formation flows back. So that means that 70 to 85% of the water remains in the formation, in the Marcellus Shale, at 6, 7, or 8,000 feet deep, whatever the depth is in that area.
So what is going to happen? What happens to that water? Our water panel people, or Mr. Komoroski?
Well, the underground injection control program that's been advanced, and one of the things that's often recommended is disposal wells. That's how disposal wells operate, only at a shallower depth. But it remains in that formation, in the Marcellus Shale formation, and as one of my other slides indicated, it's more than a mile below any freshwater bearing zone. Mr. Turner's made a remark that he's found water at 1,000 feet. It's not freshwater at that depth. And some of the other remarks he made about the Dimick situation assumes a more simplified hydrogeology than the fracture-based system that exists in Dimick.
George, I'd actually like to have you address that question, because I think that the question presumes that if the water's staying down there, that it's got to be coming out somewhere else. And what, in your professional experience, is the likely migration pathway of that water where you've got an open gas well bore?
So It is on. Okay. I can't tell you without a whole lot more data, you know, when and where it's going to come up and how. They're putting the water into the formation. They're pumping it in under the kind of pressures that I have used in shotgun barrels to drive buckshot. So that'll give you an idea of the amount of pressure that's used to push that water in there. And that water will find cracks and fractures and go anywhere it wants to. How much of it will come back up depends on what kind of fractures it finds. If there are any natural fractures in the rock that allow the water to move upward into the aquifer, it'll do that. It requires a great deal more effort and more seismic work, more detailed seismic work than what I have heard is being done to find those fractures. I think it needs to be dealt with.
So in summation, it's fair to say that with regard to that aspect, we're dealing with an unknown that could present a potential problem. Okay.
Definitely.
If chemicals are added at 0.5%, as the industry states, that amounts to 20,000 gallons of chemicals for 4 million gallons of fresh water. How is Cabot transporting these chemicals into Dimock? By tanker, truck, barrels, or how?
I mean, all the above. I mean, it's typically brought in drums or in tankers. And by the way, based on the discussion we've had with professional geologists and hydrogeologists, I respectfully disagree with Mr. Turner that it's possible for fractures to allow migration from the Marcellus at 7,000 feet deep to a freshwater bearing zone 600 feet deep. There's no such migration pathway that exists.
Okay. How long will a gas company bring replacement water? Is the questioner here? Are you referring to?
If an oil and gas well operator affects a water supply, they have to restore or replace it. The water supplies affected in Dimock are going to be restored. When? That's the law. We've got a consent order with
So
Cabot.
why did they wait 9 months to do it?
Why does Pat still not have water?
Right, why do some people still not have water?
Temporary water has been supplied.
To only some
a
families.
plan to restore the supply is being developed.
Bottles?
Ladies and gentlemen.
Your water supplies are going to be addressed. That is that's the department's job, that's the law.
Okay. How many inspectors do we have in place to monitor the activity in Wayne, Susquehanna, Tioga, Bradford counties presently?
Oh, geez. So presently, the North Central Regional Office, I believe, has about 30 people working for the oil and gas well program. We have oil and gas well inspectors, we have water quality specialists, and we have engineers associated with that program. Obviously, we're going to be hiring 68 new people. The North Central region is going to be expanded into Scranton with an office there. And they're going to have almost a doubling of their workforce.
Where does wastewater and or soils go after being removed from a site? And part two of the question, if there is a pit and it's lined, is there consideration given to the effluents that's going to evaporate and with respect to air quality?
The soil cuttings that are the rock in the soil that come up the hole after drilling the well are permitted to remain on site after the pit has been dewatered. Any wastewater has to be removed from the site, has to be properly disposed of, unless it's otherwise recycled. Then it can be used at another location for hydraulic fracturing. As far as the air emissions from any activity, there are it's often been misstated that there's no regulation of that activity. If the emissions from any operation exceeds a threshold above any significance level, and the department has significance levels for all conventional and hazardous air pollutants, then that would have to be permitted. But the fact is that the air emissions from those operations are scientifically determined to be insignificant.
Thank you. If one of the reasons for drilling is to get off foreign energy sources, shouldn't we require our gas to remain in the United States and not get shipped elsewhere? Anybody? Is it getting shipped elsewhere?
Yes, it is being shipped elsewhere. I mean, the pipeline network that exists presently allows for the shipment of it principally to the northeastern United States. I'm not aware of any being shipped internationally, but the reality is that this is something that's typically encouraged in a state, is that they can create products that can be shipped elsewhere, and you can actually bring additional value to your country, an additional gross national product. But our goal has been to find more and more uses for gas locally and to continue to use it as much as possible locally.
Thank you. Okay, we'll do two more questions. This is directed to Jim Llewellyn. If a well is shut in, is it more likely to contaminate a water supply or at greater risk?
That really depends on the grouting techniques that were completed on the well. Yes, obviously, if the pressure is greater in the well, then yes, there is more potential for impacts to, and let me underline, more potential for impacts to the local aquifers.
How close to a domestic water supply can seismic testing be done safely?
This is something that I recommend for everybody. If you have a spring, you need to be a little more concerned, because presumably that water is coming from a shallower source. So if they're running around with thumper trucks, I don't see that as a big deal. But if they're setting off charges 20 to 30 or 50 feet down, basically they could impact those preferential pathways where the water recharges through the soil into the rock and then runs right near the surface of the rock. If it creates fractures into deeper portions of the rock, you could lose a spring. I'm sorry, you say that one more time? I think there's another part to that. Within 1,000 feet?
It was, what would you say would be a safe distance?
Okay, and the other thing is, as far as the seismic and the drilling, it's exact. We tell people exactly what George said. You go out to your well or your spring, and water flows downhill, even below. Hydrogeologists, the rule of thumb in hydrogeology is that the aquifer basically mimics topography. Okay, and so you have to keep that in mind. So you stand at your well and you look off to the sides, okay, at an angle. Everything uphill of you, you should be concerned with. And you should keep, well, obviously if they're drilling in that area, you really have to pay attention. I would keep all the seismic out of that area as well, especially if you have a spring.
Yeah, I agree. Let me add one thing. When they're doing seismic work, they're sending a shock wave down through the earth, and it's going to go down through the earth a couple of miles, and it reflects off a variety of different layers inside of the earth, and then it comes back up through the earth a couple miles, and it's still strong enough to shake the seismic pickups and to be recorded as, you know, evidence of what's below. If they're going to put a shock wave into the ground strong enough so that it will reach 2 miles down and 2 miles back up, can it affect your spring? Oh, definitely. How far away is safe? Nobody can say. That's questionable. It depends on how big a charge and what kind of, what the bedrock is like and how deep it is. And what your spring is like. There may be a piece of shale just about to fall over your spring and shut it off. It's down underground, and whatever they do, a little bit of shaking causes it to happen. You know, you never know. People who have springs that I have sampled, I always take a bucket and a stopwatch along, you know, my fancy measuring equipment, and measure the flow rate of the spring too, because then I have documentation that on the day I took the sample, the flow rate of the spring was, you know, whatever I found. I usually leave the stopwatch in the bucket with the people, and I tell them, get themselves a notebook with numbered pages in it, that's a bound notebook, because then it becomes a legal document, and measure their spring every so often, write down the date and the time and, you know, the number of seconds it took to fill the bucket, and keep that record. If anything happens suddenly, they have that record that shows that the spring has produced water up till that point.
Okay, thank you very much. Does anyone have any final last words? Okay.
You know, actually, I would like to say something, because I think I understand, and the department understands the frustration that people in Dimick are experiencing with the situation here. And I want you to know that the Department of Environmental Protection is charged with enforcing the law. The law requires that water supplies be restored or replaced if they're affected. We have a consent order with Cabot. We're going to carry this through, and your water supplies will be restored.
Hang on 1 second. Let me add one more thing to that. The water supply needs to be replaced. The groundwater is contaminated. It's going to be contaminated for a lot of years. Insist on the installation of a public water system. That water system will require wells outside of the contaminated zone to supply the water, and it'll have to be piped into the people whose water is now contaminated. Guess who has to pay for that?
Okay, before you start your departure, please be mindful that we will be having a presentation on the pipeline issues in May.
Yeah, right. Thanks for destroying our lives, our whole county, and making it a horrible place to live.
You don't live here, do you?
It's not all about money.
You don't live here.
Of course it's all about money. What else could it be?
Answer the remediation.
You have to live somewhere to care.
Answer the remediation.
You have to live somewhere to care.
Yes, you do.
So you don't care. You don't care what happens to
people. Are you on
people
a public water supply or private?
Where do you live?
Does it matter?
Yeah.
I live in the county. Do you? Are you on a public water supply or private?
Do you care what happens to people in New York?
Of course I do.
Okay. Then I care about what happens to you.
Okay. Answer the remediation.
You care and I don't?
We're supposed to have the remediation answer this month.
If you have questions, I'll be happy to answer your questions.
I'm asking you. I'm sorry I interrupted, but we need the remediation answers this month, as DEP said they were going to come forth. Do we have them? Will we have them?
I believe so.
Okay, when will we know? When will there be a news release about it? It was this month that it's due, right?
Yeah, the end of March 31st.
Okay.
Yeah.
I'll be looking for it.
We'll be on time.
Yeah, okay. I can't wait to hear it.
Good. I'm glad you're interested.
More lives.
Oh, okay.
Oh, did you? I'm sorry, sir. Sir?
So are you making more money now as working for Cabot than when you were an environmental engineer?
Am I making
more money working for Cabot as their spokesperson and their attorney than when you were
compensated for being their lawyer and their spokesperson?
So is it more than you were making when you were an environmental engineer? Can you say that, or you can't admit to it?
Every attorney in my firm, their rate goes up every year. So the firm generates more revenue every year from every attorney in our firm.
And do you have any wells being drilled where you live? How close is the closest gas well where you live?
I'd say it's within probably about 5 miles at this point.
Okay. And do you have any contaminated water wells in your area?
We're on public water supply.
Oh, public water.
I have a question for you.
Yes, sir.
How much benzene did Kyle apply No, you're a perfect.
I have to mention the inspectors, 30. I know the inspectors. We had Mike and Steve for the first couple of years, and now they said they have someone else. There's only been 3 inspectors for 5 counties to inspect these wells.
We need to get more people.
But you did say to the audience there were 30 or something like that.
Within the oil and gas, I don't know the quality. You've got water quality specialists, which are different than.
But the people monitoring the wells right now, there have been only 2 for 5 counties, and now there's a 3rd coming on board. Correct? I got that from Mike.
Okay, I'll take Mike's word for it.
And he's a good guy, by the way.
Sure,
he and Steve Watson and John Ryder, they're my heroes.
Yeah, John.
But it stops there.
He's the
We haven't had really good help from the top.
Well, that's obviously going to change.
I hope so. It's a little late for dimming. I mean, this is all good news for everybody else. But it's just too bad you weren't there for us in the very beginning. That's all I have to say.